Ladies and gentlemen, what's up? Here comes a video for you, a video lesson on section 3. We just finished up discussing in class evaluating and simplifying expressions and the difference between what those words mean. And now, after your quiz, I gave you this graphic organizer. It was the pink one, looks like this. Woo, woo, that guy right there. Woo. And you're going to need that to fill out because this video is going to be filling out almost all of this. And what I'd recommend is this. Whether you do this on the back or right next to it in your notebook, I'm going to give you a running example. And what I mean by that is you're going to have an example that as we go through each of these steps on this graphic organizer, step 1, step 2, step 3, so on and so forth, I'm going to give you step 1 in the organizer, and I'm going to cut to the example and do that part of it, and then come back to the graphic organizer, give you step 2, and then cut to the example and do step 2, and then give you step 3 in the graphic organizer, so on and so forth the whole way through. So a running example is where I show you the step and then I apply it. Show you the step, apply it. Show you the step and apply it. But the idea here, you saw the essential question, is how do we actually solve? How do we use this thing called SADMAP, which is just the reverse of PEMDAS. That's all you're doing when you're solving or isolating a variable. And in fact, here's what you can do. Here's the example that we're going to use. Let me cut to it. So here's your example, and notice it says solve, and this does not say at all evaluate. It doesn't say simplify. It says solve, and here's the key distinction. You see that equal sign right there. Anytime, guys, you see an equal sign, you are going to be solving. And what does that mean? It means you're looking for the value of the variable that when you plug that number back into the variable, n here and n there, it's going to make the left side of the equation equal the right side of the equation. So you're looking for the value of the variable when you're solving, isolating the variable, that when you plug it back into the equation, it makes the equation true. Now I'm going to tell you something. I hope you wrote that down. That's a very important thing about solving or finding the solution to any type of an equation. So this is the running example, and that's cut to, let me erase this. Woo. Hello. There we go. So let's cut back to this. And on your graphic organizer, step number 1 that you need to write down is this. Change any and all subtraction signs. Now I put this little asterisk over here, guys, because it's optional. If you don't want to do that, you don't have to. And with this running example, I'll show you both ways as we do it. But changing the subtraction signs, if you remember from Algebra 1, your teacher might have taught you this, or maybe even prior to Algebra 1. You can take this subtraction sign and change it to adding the opposite. So I'll put that over here. So it's like 3, and then in parentheses, I'm going to write this smaller, else it's not going to fit. 4n, and then addition of a -2. So what you're doing is you're just changing the subtraction sign here to adding the opposite. Adding the opposite. And that still equals then 6, and then in parentheses, n plus 3. So if you want to do that, by all means do it. Do you have to? No. But I'll tell you what, if you keep getting these questions wrong as we do them, I'm going to tell you to start doing it because it helps people more times than not get the question correct. So I'm going to show you on the right side this example here where I changed the subtraction sign to addition of a negative or adding the opposite, whatever. And this side over here, I'm going to show you exactly this one. So that's step number 1. Let's cut back to this. Here's step number 2. And this is not always necessary. You don't always have to do this. But the next thing that you have to look for is, can I distribute anything? If so, do it. That is your next step. So in my running example, is there something here that I can distribute? Sure. I can take this 3 and distribute it there, and take this 3 and distribute it there. 6 I can distribute there, and the 6 I can distribute right there. So that's going to give me the following. 12n when I distribute the 3, and then I distribute the 3 over here, it gives me subtraction of a 6. And then that equals, when I distribute the 6 here, 6n plus 18. Where did the 18 come from, Mater? 6 times 3 gives you this 18. Same thing that's going to happen over here. So I'm going to pause the video. I'm just going to write it down, then we'll cut to it. So here's what it looks like. So as you see, I wrote it down here. I just took the 3 times the 4n, and the 3 times the -2, which gives me the addition stays the same. So it's actually -6 here. And then I took the 6 and the n and 6 and the 3. So it's still the same exact thing. I've just distributed. So that's step number 2. And again, sometimes, guys, you're not going to have to do that distributive step. Here's step number 3. And in fact, sometimes you're not going to have to do this step either. But it says combine like terms. Now, I have this one in a, I guess we'll call it dotted oval, because you have to be careful when you combine like terms. Go back to this example. Notice my like terms here. I have 6n and I have 12n. And those like terms are on different sides of the equal sign. So since they're on different sides of the tracks, I always say, the equal sign, you cannot, remember from Algebra 1, just take the 12n and the 6n and combine them and get 18n. That is incorrect. The way that you can do this, and the only way that you can do this because they're on different sides of the equal sign, is you have to actually subtract away the 6n because you want this 6n to disappear. And since it's a positive 6n, the way to get rid of it is subtract, because that will give you 0. And as you remember from Algebra 1, what you do to one side of an equal sign, you got to do to the other side. So I'll do that here, and then when I do that, I combine these, which gives me 6n. I bring down the subtraction of 6, that's still the same, nothing changes there, equals. This is gone, that's now 0, so it's out of there, peace. And then I still have plus 18, so a positive 18. And by the way, likewise, the same thing happens over here. So notice that when I subtract 6n, these disappear right there. And then add this together, you get 6n. This is still, whoops, a addition of negative 6 is what it would be. Yeah. Addition of negative 6. And this 18. So it's still the same thing. So that's step number 3. Change subtraction signs 1. Distribute if necessary 2. Combine like terms. Now, you're getting into the step number 4, which is almost always going to be used. You have to undo this subtraction and addition. So that is step number 4. So let's cut to our example. Undo addition and subtraction. So that means this. My ultimate goal when I'm solving this equation, like I already put there for you, is you have to get n by itself. I'm looking for n equaling something. Something. So I need to get this thing then by itself, and what's right next to it is subtraction of a 6. How do I get rid of a subtraction of a 6? I undo the subtraction by adding a 6. Over here, I have to undo the addition of a negative 6, and some of you might think, oh, that means I'm going to subtract. No, because if you subtract, a negative 6 and a negative 6 does not disappear. So how do you do that? I got to add a 6. Same thing I did over here. Cool. So when I add a 6 on this side, or add a 6 on that side, I'm going to get the same exact thing. So now I'm going to write the same thing for both of these because they both become the same thing. These guys disappear. These guys disappear. I'm just left with 6n equals, not 18, don't forget, haha. What I do to one side, I must do to this side. So I got to add a 6 right there. I would do the same thing over here, add a 6 right there. Bam. So that gives me 24 here, same thing like I said. So you're finally down to this simple little equation. 6n equals 24. Let's go back to our graphic organizer and get step number 5. So step number 5 is this. You now need to undo the multiplication or division. So back to this, I would simply undo this multiplication here of 6 by dividing by 6. So when I divide by 6, I got to do it to both sides because it's an equation. It's got to be equal. So I then have 24 divided by 6, which gives me n by itself. Finally, we got n by itself. We've isolated using SADMEP. And we got n equals a 4. Now apparently, guys, this is my solution. I don't know that yet, but apparently that's the value for the variable n, that if I plug it in up here into n and end, well, n and n, that's weird. Sounds like I'm stuttering. It's apparently going to give me a true equation. So let's roll on to our very last step. Side note, this stuff in gray, this oval in gray and this little box over here in gray, we're not going to get to that until we get to section 6, because that's where we talk about linear inequalities, and we use this same exact steps, except there's one little thing we have to be careful with, and then one other thing we have to do when we're doing linear inequalities. So do not get rid of this graphic organizer. In fact, you should always laminate it and keep it for the rest of your life. That's my opinion. But you definitely need to leave it in your book bag and in your notes until after chapter 1. So here's the last thing we're going to fill out, though, in this part of this video. Last thing you got to do is check. Check, baby, 1, 2. Woo, woo. You have to make sure that you check your answer. How do you do that? Well, you have to take this apparent n equals 4, and like I said, substitute it back in there for the n, and substitute it back in her for that n right there. And apparently, if that's the case, the left side of the equation is going to equal the right side. If that's awesome, you got your answer. If it doesn't, then you made a mistake somewhere, and it's not your solution. So, check this out. Bam, I already did it for you. So when I take the 4 and plug it in for the n, which I did right there, and I did right there, I plug that in, and now I use my order of operations. So the next thing I do is do this 4 times 4, and it gives me 16. Over here, I just kind of kept it the same, so you see it's exactly the same. I keep using my order of operations. 16 minus 2 gives me 14. 4 plus 3 gives me 7. And now on the left side, you see I get 42. On the right side, you see I get 42. Woohoo! Time to rejoice, baby, because that means you have a correct solution. What's the solution? 42 equals 42? No, it's this. N equals 4. That's the value of this equation, rephrase, the value of the variable, n, that when I plug it back in, gives me a equal equation. 42 equals 42. So, ladies and gentlemen, there you go. There are your steps to solving any linear equation. We're going to practice, and we're going to master solving any type of linear equation. By the way, we're going to do this in class over here to the right where it has this little box. Sometimes you got fractions in there. And if you got fractions, we have to do something with it to continue this. But notice, it's not one of the first things we do. It's actually one of the very last things that we do. So, I'll see you in class. Peace!